Hey everyone, welcome to the third Interface Engineering High Performance Buildings webinar series. I hope you guys are all good. We're gonna start today with the topic of energy modeling and optimization 101. My name is Arash Zarmeh. I'm mechanical engineer and modeling and simulation engineer. I will try to present you today what we have to do energy modeling and optimization. This course is eligible for AIA credit. Course number is M200425. Let's start with the course description. What we're gonna learn today, this course was developed for design professionals in field of architecture, engineering, and for leaders in the built environments. The course focuses on a methodology and approach of building energy modeling for both new buildings and modernization of existing buildings. The course covers the fundamental of building energy modeling and explains how to use modeling to guide design decisions. Also, course participants will learn how to integrate modeling into the design process from the programming stage through the post-occupancy and measurement and verification. The course explains modeling principles and provides modeling tips related to the building envelope, plug loads, lighting system, and HVAC systems. They are all inputs. Also describe is the appropriate use of modeling throughout the project lifecycle. The course concludes with a guidance on a model calibration and the use of energy modeling for measurement and verification. What we're gonna learn in this webinar today, we're gonna talk about the fundamental building energy modeling, the history, the definition, the standards, what are the fundamentals, and then we're gonna talk briefly about the energy modeling and analysis process. What are the procedures, where to start, where to finish, and what are the expectations. And then also we're gonna talk about the Appendix G for performance rating method. That's one of the standards, the main standard of building energy modeling. And we will talk about the effect of energy conservation measures, which they are strategies to reduce energy use. And also we will be able to analyze energy modeling results with different case study projects. We will talk about the introduction of energy modeling and analysis process, energy modeling case studies, and then finally we will go over conclusions, and I will leave 15 minutes for Q&A so I can answer your questions if there is any, and then also we will have a document of responded to all of your questions. If I didn't have a time to finish all of them, we will answer all of your questions in a document and we'll send it to you. Let's start with introduction of energy modeling. What is really energy modeling? We call it BEM, building energy modeling, which is physics-based software simulation of building energy use. The objective of building performance simulation is quantification of aspects of building performance which are relevant to design, construction, and sometimes operation. So they are in three different aspects. Let's just briefly go through the history of the building energy modeling. When we talk about the energy modeling, everybody thinks that just in recent years, just few years ago, it is started or something, but the answer is no. Energy modeling history goes back all the way to the first time that computer was actually invented. Developed in late 1950 and early 1960 in United States and Sweden. The reason was because it was very important aspect. So it started from the single system component analyzing, such as gas boiler, and also with the steady state calculations. The first developers simulation tool, what was called BRIES, which was built in 1963 in Royal Institute of Technology. It shows how old is energy modeling, how big history he has, and it was started from long time ago, from the start of the computer. But it accelerated, and it came on very important domestic policy interest, urgent domestic policy interest since 97 energy crisis in the United States. That was a time that first standards of ASHRAE 9075 was implemented and introduced to go through the energy efficiency building, which was very important and help us to accelerate doing building energy modeling and simulation. And why energy modeling is really important. So as we see that 48.7% of building energy, general energy consumption in the US are buildings. Not only buildings are a majority of energy consumption, they are a majority of, they have contributed in a majority of carbon emission. They have a big carbon footprint. So if we be able to save the energy on the building energy efficiency with the energy modeling, this is why it is important to do that. And why do we need to do the energy modeling? This is a question that professionals and different people ask, that why really we have to do in the real world energy modeling, do the simulation. That's a cost, that's a time, that's everything. There are different reasons. First and foremost important is a regularity. There is a local permit requirement. If you want to get a permit, if it is a school in Washington DC and it's a LEED Gold, you have to get that. You have to have a energy modeling to get a permit. Also for green certificates such as LEED, you need to have you need to show the energy modeling reports. And one of the most effective one is an informed, educated decision. It will help all stakeholders, from the owners, designers, engineers, and blah blah blah, make a right decision at any phase of construction and renovation. And the third one is a business incentive. What is that? It can be a local, it can be a governmental, such as FAR. We have in some of the counties around the Washington DC or Virginia, Northern Virginia, that people can use energy modeling as on their business incentive, can be make more money. It can make different tax credit or stuff. So these are the three main reasons in a real world that we do the energy modeling. So before we start and go through, we know the history now, we know the definition, we know the reason that we have to do the energy modeling, and now where to start. The first thing that we have to start to do the energy modeling, to start to go through the simulation, building simulation, is to know the standards or guidelines. That's important because anything in engineering should start with this kind of standards and the guidelines. So for energy modeling, the first one is ASHRAE 90.1, which the best chapters are Appendix G, which is a performance rating method. That's specifically for energy modeling. And there is a chapter 11, which is energy cost method, that shows how to get the results for the cost modeling. Also, there are different ASHRAE guidelines. There is a 90.1 user manual. There is an ASHRAE 140, which is a standard method for test and evaluation of building energy analysis program, computer program, and also ASHRAE 209, which is the main reference for doing the energy modeling, energy simulation aided design, and guideline 14 that I will talk about it, why we need it and why it is important to do that. I will quickly go through the energy modeling and analysis processes. Let's start where we have to. Okay, right now we know the history, we know the definition, we know the standards and all the basics. We want to start where we have to start. Where we have to start our energy modeling. The first and foremost important step is we have to identify target and goals on pre-design construction, on existing building construction, or whatever is that. For doing energy modeling, at the first step, we have to know where we want to go, what we want to get from our energy modeling, what are the things that we need to get it off. Then we have to identify required energy modeling standards, and we have to identify the local guidelines, because place by place, location by location, they are different, and it's important to know. So if we want to take a look at the general overview of the energy modeling process, is that there are a set of inputs and default variables, there are calculation engine, and there are outputs, and the program delivers. So as a set of input and default variables, they can be building energy, geometry, massive, form, system types, operation schedule, and etc. For engine, we can use different engines that I will talk about them, and energy output, which can be a performance comparison graphs, compliance report, and etc. So if we want to talk, somebody say, okay, energy modeling is for the design process also. It is only for design process. It is when we want to just doing a new construction. The answer is no. Energy modeling has capability to work and show that efficiency and high performance building in a new construction and existing building under renovation. The overall process on those are different. For new construction, every energy modelers need to define and find the two different energy modeling: baseline, which is the minimum code, minimum standards of the location of the site and everything, and a proposed, which are based on a design document. Then for existing building and renovation, it is a little bit different. We have existing condition, we have a criteria, existing criteria, we have a calibrated model, and then we have a proposed, and we have a design document. So if I want to start with then energy modeling development for building design and construction, new building design and construction, this is the overall. I'm sure that most of you guys are engineers and professionals, are familiar with the building design and construction process and steps. So owner's project initiation, there are schematic design, design development, construction design, and construction administration. This is the general and overall processes and phase of the construction. Energy modeling for building design and construction, new design, will start from the early design, from the pre-design event to schematic design, all the way to the CD, and sometimes even if there are updates, if there are new decisions going on, it can continue to the CA. Usually, it is suggested, and it is suggested to start in a very early design. It is cheaper for owners and designers and engineers to go through the energy modeling, go through the process, and make a what-if scenario to understand where are they and what are the different benefits that they can get. They can, in a schematic design, they can define a goal. They can check their option ideation. They can apply different energy conservation measures to see what are the changes if they change everything. And that's very important, that energy modeling can help engineers, designers, and owners to decide in the right path and make a what-if scenario. Say, what if we use that? What if we change our glasses? What if we change our HVAC system? Before anything happen, before any design happen, energy modeling can make a sufficient and a big help for engineers and designers. But still, we can do it in a CA as well to help the decision, to update the construction administration staff, to help the owner to decide if they need to make any changes. The process I changed it in two different phases. STDD, or early design, is better to call it early design, and in a later design. For early design, we define the goals, we identify our inputs, we're gonna initiate our results, first results coming out from the energy modeling. Then we will apply energy efficiency measures. Different thing. Do we need double pane glazing? Do we need triple pane glazing? Or different envelope HVAC or electrical and plumbing? So then we're gonna find out we're gonna do the result assessment for after we have a different type of the results from the ECMs, and then we can optimize our design, rerun a simulation, and help the designer to make a final decision. For other processes, we say, okay, we have energy modeling from the earlier design. We will update our design criteria based on a new thing that we want. We want, for example, to change the part of the HVAC system, and to see how you're gonna change it to the main design and building behavior. We have two ways. We can do the simulation. We can go get the contractor, build that piece of equipment, and then test it. So which one is more expensive? Which one is faster in terms of time and cost? So energy modeling gonna win. So we're gonna, for that part, we can do the energy modeling for a single component and then take it to the whole building simulation. Sometimes the just single component can help owners and the stakeholders to decide what they want to do. Sometimes we have to do both, and sometimes we have to do only the whole building simulation if we need the regularity for lead and permit document. So in generally, a new construction, I just explained that we have two different energy models. We have to build two different energy models of the baseline and propose. Baseline is a minimum code which has an input based on a minimum code, and it has an output. Then proposal coming from the design documents, it has an input and it has an output. Then we are able to compare the output from the baseline to the output from the proposed, and just talk about that how our design and how our engineers design are better compared to the baseline. As I said, proposed is a computer representation of the actual proposed building design, used as a basis of calculating for the design energy cost, and modeling matches the actual design. And then we have a baseline, which is a minimum code and a standard that usually in the US are based on ASHRAE 90.1, or it can be from the local standards required. So we know the general process of new construction building. We know the standards, we know what we have to do. Right now, I want to go over the tools. There are tens of tools around the world. There are online platform tools. There are different type of tools, but I will talk about some of them here that we usually use in the US is DOE2, Open Studio, Energy Plus, IES, VE, and Design Builder and TrainTrace. The three of them, which are Energy Plus, Open Studio, and DOE, are freeware and integrated environmental solution, or IES VE, is a commercial license. Design Builder is a commercial builder license, and TrainTrace are commercial license. In our office and in this webinar, most of the things that we're gonna see are based on an Energy Plus and IES. But mostly our Energy Plus, because that gives us more flexibility to define the inputs and define an output and make different changes based on a project complexity. So we know the tools, we know the standard, we know the definition and everything. I will start with an input. So output, if you remember from that slide, that in an overview of the energy modeling process, we have input, engine, and output. We talked about the engine, and now we are talking about the inputs. What type of inputs we want for energy modeling? Any computer simulation, any computer programming needs something, some variables to go to the simulation, and some variable goes up. So here I'm going to talk about the inputs. Geometry. This is important because some people think that geometry can come from the architectural drawings, which can be wrong. The geometry of the energy modeling is good to be built by the energy modeler because they have to have a flexibility to define their thermal zoning based on the mechanical electrical systems. And then we need material properties, construction assembly. And other important inputs are building operations. They are very important, number of occupants in it, because we want to do the real-time simulation. We need the number of occupants in the future, interior light powers, plug loads, there are electrical, cooling and heating set points. They are different by different type of buildings. It can be residential or different, commercial or different, schools are different with an office, and etc. HVAC and operation schedules, service hot water consumption, elevator power, miscellaneous equipment and process loads, infiltration and ventilation. They are general building operation inputs. HVAC and power system inputs, which are most important part, because HVAC system are the biggest energy consumption in a building. So we have to define every single aspect of HVAC design from the design documents or from the standards, such as air side cooling and heating system, water sides if we have, or plant side cooling and heating, electric transformers, thermal storage if we have, ventilation and thermal comfort, and if there is a building energy management systems or optimization and control system. Also, that is important, that where is that building? We need to know the site specific settings, design days, location, time zone, daylight and saving and holidays, and utility rate structure. One another thing that is very important is the global setting, output. This is very important, that define input in output, define an output in input. Why? Because we want to know what we want to get from the energy modeling. We have to specify that output. I will talk about it. Just in general, remember, sometimes over 500 inputs and default variables need to be identified for energy modeling to get the accurate data out. One thing that I have to say, I'll talk about the inputs. If we take a look at it, we need to update. Energy modeler needs an update energy modeling data inputs. We need to know where are there. So if we talk about it in overall, based on it, inputs that I define on the right side of the building, 40%, for example, is HVAC system, 20% is internal heat gain from lighting. In overall, if I want to say where is energy modeler should be part of which team, what is better to put the energy modeler in which team, I can say that MEP designers, MEP, I mean, there are variety of teams that doing energy modeling, MEP commissionings, architects, sometimes sustainable engineers. But I want to say that if the energy modeler be part of MEP designers, he or she has an access to over 75% of the input data. Update, it can help the design decision making of the 75% of the data, and can be very helpful if energy modeler be part of MEP. So I go back to the propose and baseline. I define the general inputs as a 10 chapter of the 10 chapter inputs. We can just compare them. What are the baselines and what are the proposed? What are them can be different in this 10 chapter table, which coming from the ASHRAE 90.1 Appendix G. It helps us to know, for example, design model and schedules and space use classification. They have to be the same as proposed and baseline. If we define the baseline from the architectural drawings and build our geometry, we have to do the same thing with baseline. But in some stuff like building envelope, they are different. For baseline, we have to use a minimum code from whatever is defined in ASHRAE standard 90.1. It can be 2010, 13, recently 16 and 18, and for proposed, we have to use for whatever is in a drawing, design drawings. And so we know the inputs, and now we want to go to the output. We have a general output, such as EUI is the most famous output of energy modeling, energy use intensity. That's a kBTU per square feet or kWh per square meter. We can get the annual energy consumption, end use energy breakdown, annual energy cost, temperature trend, energy cost, temperature, load profile, and etc. And also we can have a custom output. Depends on what type of a project we have. Maybe we need a specific project. With Energy Plus, ISVE, and Open Studio, we can define our output. We can categorize and specify what we need. If we have a geothermal, we need to specify output for geothermal, and we can just specify that. This is a specific, this is the general output from one of the projects. I will talk about it, but this is an overview of the, we have energy use intensity, we have different energy use breakdown, and cost, annual, peak, and load profile. So I talked about the new construction. The existing building is overall the same, but we want to quickly talk about the energy model development for existing building. One point that I have to mention is that existing building are majority of percentage of potential saving. Most of our buildings in our communities, in our societies, are existing building which are not energy efficient. Maybe the new construction are more efficient because of the restriction on the new laws, but to me, I think doing energy modeling for existing buildings and help them for correct renovation in terms of cost and energy is more important than sometimes than new construction. I'm saying that both of them are important, but I think I'm saying that we should not forget about the importance of that. Let's talk about the overall process. Owner design, building energy analysis should be initiated, should be performed, detailed study based on the built energy consumption. We need to know the current building envelope and equipment criteria, current operation criteria. When we gather all those information, we develop our initial energy modeling. Then with the guidelines, we can calibrate that simulation to be very close to the current energy consumption, and then we can build the energy master plan based on a proposed design for renovation and doing a correct renovation. In energy modeling in existing building has capability to help owners and designers to decide correctly. Existing building has, I just talked about it, I go briefly. Build energy proposed design, build energy, then existing calibrated simulation based on ASHRAE guideline 14, which has a direct standard and guideline to how to calibrate our simulation. The general process is that we have existing, we get our inputs based on existing energy building conditions, then we get our existing energy model results. Then we calibrate that result with the guideline, ASHRAE guideline 14, and then we can finally calibrate that model output, apply different ECMs to help the stakeholders to decide, and finally we can define and identify our final comparative outputs. So I just talked quickly in these things to know about the general process, but we get to the most exciting section of that I want to talk about it. I want to talk about some cases studies and projects that we were implement. Let's talk about the first case study number 1. I want to talk about this project. It is 155,000 square feet in downtown DC. That's a new construction embassy. Energy modeling started from schematic design phase, from even pre-design, from very early stage of the building design. The building is LEED Gold. So the reason that energy modeling was done are because of the permit and green certificate regularity, and also to help the informed, educated decision. Let's take a look at the why I choose this building to talk about it with you. This building, this embassy, new construction, is fully glass with very complex facade. That was a very hard to the stakeholders to decide what type of a glass they have to define, what type of a facade they have to decide to get to the target and goals that they have. Be able to get the lead, be able to get the permit when the building is fully glass. So the building was built in a real environment. The building is in downtown DC. The EUI for baseline was 53 for the same building with the same glass, with the same effective structure. And the first EUI with the first ECMs apply and the design procedures, we were able to show how with the initial results we can get the building to 37, from 53 to 37. So this was the first initial design that in a schematic design was happen and helped the stakeholders to decide how to go. This building has different restriction, has different specifications. So one of the things that energy modeling was helping to the designers and architects how to decide about the fins on the glass type. If you see on a facade, there are specific fins and a specific facade thing that if architects wanted to decide themselves without doing energy modeling, it was unachievable without consulting with the energy modeling. It was how could they know that how is that facade performing? Just guess, just going on the general energy knowledges of engineering, or just build it and see what's going on, which is costly and time consuming. At the end of the project, after all of the ECMs apply, after all of the design specification applied, EUI was going down all the way to 26. And we were able to get the permit and green certificate for this building. It was a high performance building. We helped the designers even in CA. It started from CSD, schematic design, and we went all the way to construction administration. So it was very important that even when they decided, for example, I remember just they wanted to change one piece of a glass in a south face and they didn't know what to do. So energy modeling helped them at the CA phase, which if they wanted to buy that glass, install it, and then change it, it was costly for them. We helped them to decide to change the type of and brand of the glass type in that specific section. So case study number 2, if I want to talk about the case study number 2, that's a specific project. I like that. It's 71,000 square feet. It's located in Dakar in Senegal with very unique weather and climate specification. That was a new construction. And the thing that was very important is that it was a net zero building in that climate type, which you cannot have any heating. That's a cooling only. So energy modeling entered in a very early design from a schematic design. It was only for informed, educated decision. There was no regularity. There was no business incentive. It was only to help the owners what to decide to move forward. And let's see the importance of the energy modeling in that building, that specific weather, very hot and a special location. Applying ECMs, as you see in the right corner of the results that I'm showing, there was different ECMs applied, such as add an economizer to the baseline, a radiant ceiling panel, a specific PV location, even though we were able to help the designers how to decide where to put their PV model. And this is important that we reach net zero building, and it was not achievable without energy modeling help. Case study number 3. That was another specific project in downtown DC. Okay, we had the project. The first one were embassies, second one were offices, and this is the third one, which is a Holly building. I want to talk about it because that was some interesting project that I like that. It's a 101,000 square feet in downtown DC. It's a mixed use of existing building. It built in 1992. It's an office and Holly building. The point is that that building had almost $500,000 energy costs every year, and EUI of 178, which typically for that size of a building and that type of a building per Energy Star median properties in the same location should be around 85 in a worst case scenario, but this building had 178. The reason that we did the energy modeling was informed, educated decision for owners, and it was existing. So the first thing that I want to show you is that, okay, that has a $500,000. The owners came to us and said, I have a $500,000 every year and I need to do something. So we performed the energy modeling. We got their bills from 2018, 2019, as you see in the screen, from their gas consumption, their electricity consumption. 2018 is blue, 2019 is green, and then simulation was performed and is a red dash line. Then we did the calibration of energy modeling. This is actually the simulated energy modeling. This is the calibrated one per ASHRAE guideline 14. We were able to calibrate our energy modeling, and after that perform, two things happened. First, we were able to talk with the owners and designers that what are the problems, because they had a big heating, space heating costs in the summer. We were able to discuss that. That energy modeling showed that, energy analysis showed that, and we were able to show the owner that how they can change that based on their operation, based on their specification of the HVAC and mechanical system. And then also we were able to propose them a new system, how to renovate their building in mechanical and in architectural system to reach the higher efficiency and high efficiency building and renovate their building in a right way to not only save thousands of dollars of money to get the high performance building, and definitely were not achievable without using energy modeling. Case study number 4. It was 500,000 square feet garden style residential community in Massachusetts. It was a major renovation. It was 404 apartment built in 1970. Energy modeling simulation were done, calibration went out. There are 2 points that I want to talk about it. First is that I want to show that energy modeling has capability to be done for urban study. We cannot say, okay, we just need to do one building. No, we can do over this community was over 29 buildings. It was exactly 29 buildings actually. So we can do the urban study. We can propose and help the communities to save the energy. This energy modeling was performed not only for informed, educated decision, and also business incentive, because they were able to use different governmental tax credits. So energy modeling shows that with only this table that we can see in the table in the screen, it's only with one improvement in envelope, which was just patio door window replacement, which it's a green line, is a with improvement envelope. And it was only patio door. That's only changes that were, I mean, all the glass type, all the glasses were improved, and then with the improvement in a mechanical system. using geothermal for that location. Just with HVAC, I want to say 90% HVAC and then 10% envelope, we were able to show that how owners can save 22.4% energy and 22.5% energy cost saving. So we were able to help the owner of the whole community, the urban, the whole community of 29 building, they can save 22%, and that was a big number. And then it goes for proposed design. Case study number 5. I'm sure any of you guys were just following us in different last two webinars that we had. You should be available with this building. This is a pretty interesting building. That is an AGU building. It's 87,200 square feet in downtown DC. It was built in 1990s. It's pretty interesting and amazing building, and I want to show that what a crucial role energy modeling were played to reach the net zero building. And it was definitely, there were no other way to reach the existing building in this building in the downtown DC to net zero without helping energy modeling. So it is existing building, as I said. It was the different ECMs, energy conservation measures, over 25 different ECMs that I'm showing just 10 and 11 of them in this picture were applied from the early design all the way to the final renovation to reach the net zero and positive energy. This is the highest LEED rating in nation capital building. This is a building with first net zero office renovation in nation capital also, and that's a LEED platinum. We were doing energy modeling to inform the educated decision and also regularity. Just let's take a look at it quickly to see how it was helping to reach the net zero. Different and specific and special energy conservation measures were applied to this building. If you listen to our last webinars about the sewer exchange, okay, somebody, one of our engineers comes out and said, "Oh, we have a sewer exchange. Can we use that? Does it really save us energy? Does it help us to reach net zero?" What happened that that's a new kind of a technology in the US. Is not very common. It's not something that everywhere they do it. Maybe it is in Europe and other countries, in Canada, but it's not in US. So how can we really trust that idea to use sewer exchange for office renovation to reach net zero? How can we happen? The answer is only energy modeling. The only thing that we can do is the energy modeling. High five. I don't know, using a DCV. Okay, if there is a if we are adding a DCV to our HVAC system, and there are, I don't know, maybe $100,000 expense, does it worth it really? Does it save us energy that much? Then also in renewable energy, we had 4 different PV options. We were able to show that how we can reach to that 4 different options with energy modeling to reach the positive and zero energy. And one point that I have to mention, that this building, with help of energy modeling, was able to reach EUI of 10.7 for the first time in the nation. We don't have under 12 for just energy use, and that was how energy modeling helped to reach that number. That I personally call it an amazing number. That was the exact and unique help of energy modeling. So we just review a couple of 5 case studies, some projects. There are a bunch of projects there. There are a bunch of different specifications, different things that we can use the energy modeling. But let's just take everything. It passed very fast, but let's just talk about some bullet point of what we learned. We learned everything about the basic and fundamentals, standards, what we have to do, the process from the input engine and output, and then we review some of the case study to understand why we have to do that energy modeling really. So just let's review some of the bullet point conclusion. Energy modeling is an essential component to any building design and can dramatically improve both the efficiency and function of the build. Also, energy modeling is a comparative tool, not a predictive tool. This is one thing that I want to say, that some people do it with the measurement and verification. They want to talk about it. Energy modeling help to decide to compare the building with whatever is a minimum code, whatever is existing, and whatever that's something to compare. And if there are costs that we can talk about it right now in a design process, maybe we cannot talk about it in the future because of the maybe climate change, maybe operational change, maybe different stuff that change after building really goes to be an occupant and going on the real world maybe is different. So this is important. We know that energy modeling is a comparative tool and it's not a predictive tool. And there is another thing, that no modern high-performing design is achievable without energy modeling. I talked about it in my last case studies to show how it is important that we have to have energy modeling. We must have an energy modeling correct and accurately to reach the high-performing design. One more thing, accurate energy model is a complicated process. Building is complicated. There are thousands of different components in a building which are going to be designed, which are existing. So energy modeling is a complicated process and must be done in the right way to reach the accurate one. And another point, energy modeling result analysis and QC is as important as identifying accurate and correct inputs. When we got our inputs from the design models and we said they are the best one, they are the most updated one from mechanical, from architectural, from electrical and plumbing, and then applying to our engine and calculation, then we cannot say, okay, that's it, we got our results done, we're good to go. No, we have to do the QC. We have to go over whatever output we define and we need for our project definition and goals to find out if they are correct, if they are accurate, and if they are everything is going well. And the final bulletin point, energy model should be implemented in very early design phase to help to put all the stakeholders in the right path. Thank you very much. I think we got to the end. We have 10 minutes. So if you are really real and not modeled and not simulated, ask me your question. I'm here about 10 minutes to answer your question, and also we will have some QA documents that will be sent to you after webinar. Let me see the questions of what can be there. Oh, there are a couple of questions. Let me bring this up. Okay, yeah, I got it. And they said, are we getting the presentation and recording? Yes, we will get after webinar. We will send you, and also answers to your Q&A complete document. There are lots of questions. They said in DC area for a single building, are the models all using the same program to meet different requirements? If not, how many different programs might have to be run for the same building? For the same building, yes, we have to use the same program. But in generally, based on a local law, for DC, it can be Florida, it can be Virginia, they have a specific requirement of an accepted program. We can they can be Energy Plus, they can be, for example, Florida has IESVE, DC has Energy Plus, IESVE. We have to go over the local guidelines. But for the single building, yes, we have to use the same energy modeling for baseline and proposed. We cannot use two different things. They say, is it possible to explain the design builder more? Just something that I have to mention. Base of the design builder is Energy Plus, except that it is more interactive tool because Energy Plus is a Python code and it's mostly computer programming phase, and it's a little bit not that much interactive compared to other programs. So Design Builder is working based on Energy Plus generally, with the difference is that it is more interactive tool that is easier to use. They ask, can Revit perform a good energy modeling analysis? I want to say, if you're asking me personally, I say no. Revit, recently they have a plugin to the Energy Plus since early 2020, but the problem of Revit is that there are some constraint and limitation which they don't perform a correct one. If specifically, if we want a very complex system, very complex mechanical, electrical systems, it is impossible to use Revit. I personally don't use Revit, but it depends. They said what are some skills we must have to be able to enter this field? It depends. First of all, I want to say you have to know about you have to be kind of an architectural, built environmental engineer. I want to say you have to know definitely mechanical engineering. That's a majority of your needs every day. And you must know the basic computer programming and basic computers if you want to be successful in this field. I personally has two degree. I have master in mechanical engineering, and also I have a master in modeling and simulation, which is a computer science base. But it is important to have the basic of computer science to be able to grow and develop yourself, be able to play with different software, and to get the right and accurate energy modeling. How to design. And they ask, I'm a student who is interested in learning energy modeling. Which software is best and beneficial to start? I said that, but Energy Plus is a good software to give you a flexibility to work with different projects and different complexity of the systems. and it's freeware, you can just start with that. OpenStudio is more interactive part of the Energy Plus, so I recommend that for a start, really, to start with OpenStudio, and then you can expand yourself with the Energy Plus, and then in the future, if you need a very high complex facade and building geometry systems and more complex designs, you can go through the IESVE, which is a commercial license. So and they said how to QC them all after okay, I have just 4 more minutes. How to QC them all after you're done with simulation? Is there any formal procedures? Yes, there are some QC. We have a QC document in our office ourselves, but yes, there are different stuff. I will reply to you with the Q&A document. They said, I have heard about IDAI software. I heard about that software as well, but I don't know where it is acceptable, specifically if you are doing the energy modeling for regulation. You need to confirm with that with the local guideline and standard to make sure that you have a correct software. Again, they asked, does US GBC use Energy Plus for LEED? Energy Plus is one of the tools that are acceptable for LEED and green certificates. Yes, Energy Plus, IESVE, they are all accepted. DOE2 and Train Trace, there are a bunch of them. So I think we have. They said, how do you enter geometry? That's the last question I think I can answer now. How do you enter geometry information into your models? A SketchUp with plugin. A SketchUp with plugin is one of them. Yes, that's the most usable software to build your environment and geometry in SketchUp, and then with the plugin, take it to the, for example, if you use Energy Plus, then take it to the Energy Plus. Some of the tools, such as IESVE, it has their own geometry builder, so you can use their own themselves. But for Energy Plus, yes, we do it in a SketchUp and use a plugin to take it to the software. So yep, I think I have just 1 minute, so I will go. I want to invite you guys to our next session of the Interface Engineering High Performing Building free webinar. Please join us with the building design responses to mitigate COVID-19 virus threat, which Roger Frester gonna talk about it, and I hope you guys will enjoy this webinar and next webinar, and thanks for being with us.